This is Algebra 2 at Trig 1D.1a. We're going to solve systems of equations by graphing. A system of equation consists of two or more equations. The equations can create graphs. The graphs could cross once with one solution. They might not cross at all, making them parallel to each other, or two equations could actually create the same exact line, and that would be called infinitely many solutions. The solution of a system is where the graphs intersect, where they cross. So if the graphs are going to cross each other, then the lines will intersect, which means the slopes are going to be different. If you know you have two equations with different slopes, then those two equations that form a straight line are going to cross at one location. If your two equations create graphs that do not intersect, there are no x and y values that work in both equations. The graphs are going to be parallel. And if the graphs are parallel, we've learned in our geometry classes that the slopes are the same. And in this case, the y-intercepts will be different, so you have two different lines. For infinitely many, that's a little harder to visualize. You have two equations that create the same graph. The lines overlap. The slopes are the same, and the y-intercepts are the same. And that would create two graphs right on top of each other. So it's the same equation. They simplify down to the same equation. Let's try it. These are linear because x is to the first power. So this is in the format of y equals mx plus b. And that's easy for us to graph because we can see the slope, we can see the y-intercept. The y-intercept is -2, so we go down on our y-axis, 2, and we do our slope of -3, +1, +3, -1, +3, -1, and we use our straight edge. That's our first equation. Now we're going to graph our second equation. So I'm going to move the 5x to the other side. These are unlike terms, so they cannot be combined. I'm going to divide to get my y by itself. That gives me y equals -5/2. That's my slope. 2/2 gives us 1. So that's our slope-intercept form for graphing a linear function. So we go down to -1. Now this is kind of weird because it's so close to the other graph. But there's our -1. And we do a slope of -5. So we go down 1, 2, 3, 4, 5. And that means we have a +2. We can see that it is a different line, but it's really close. Then we go +5, -2. And that hits it right on that intersection. So the lines do cross, the lines do have different slopes. They're just really close to each other. Not my favorite picture for a set of notes, but that works. So we can see that they're crossing here at -2, 4. That is the solution. It has one solution. And that one solution is negative 2 comma 4. If you plug negative 2 comma 4 into your equation, negative 2 is going to make positive 6. Positive 6 minus 2 gives you 4. If you plug negative 2 in for your x, you get negative 10. Plug 4 in for your y, which would be 8. Negative 10 and 8 give you negative 2. So it makes both equations work out. So I'd encourage you to pause the video, try to work through this, come back and I'll walk you through. Pause the video. Okay, welcome back. So neither equation here is in y equals mx plus b form. That's called slope-intercept form. So we're going to move the 2 across, the 2x, subtract it across with the positive 4 that's already over there, and we can graph that. We're up at 4, and we do down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. You can even go up 2 backwards 1. And there's your equation. There's your graph of that equation. Now we're going to take the second graph, second equation. And we're going to move the 4x over. Those are unlike terms, so we cannot combine them. We divide by 2. So I'm up at 1, and I do my slope of negative 2 over 1, down 2 over 1, up to positive 1. And if you notice, those two lines have the same slope, but they have different y-intercepts. So that means the lines are parallel. There is no x and y that is going to make both equations true. Okay, here we have how many solutions are possible for a system that has one line and one parabola. We call it a system because it's going to have two equations. One equation of a line, one equation of a parabola. How many solutions are possible? How many different situations? With two lines, they might cross once, they may cross never, and they may be the same exact line. What's possible with a line and a parabola? You have to know what a parabola looks like. Parabola is a U-shape, and a line can cross it twice. So you could have two solutions. You could have a parabola and a line cross it exactly once. You could have one solution. Or, of course, it's possible to have a parabola and a line with no solutions. They don't cross at all. They can cross twice, cross once, then cross no times. How about a line and a circle? Can you picture a circle? What could we do with a line and a circle? It could cross twice. It could cross once. Or it may never cross. If it crosses twice, we would call that a secant. A secant is a word you learned in geometry. A tangent is a word you learned in geometry. The radius is always perpendicular to that tangent line. And these are just separate from each other. Okay, on the flip side, we seem to be missing a little bit of our graph, but luckily we don't need it. What type of equations do we have here? What type of equation is this? Is it a parabola? Because it has x squared? Is it a circle? Because it has x squared and y squared? It's definitely not a line. A line is going to have x to the first power. So yes, it's a circle. And to be a circle, we would like to move the constant number over to the other side. So we know that our center, you know your standard form of a circle, would put your center at the h and k. Well, we have no parentheses. We know that the h and k would be 0. So that means the center of the circle is at 0. 0, 0, right at the origin. And a radius squared is what your equation is going to equal. So the radius itself is going to be the square root of 25. So we have the square root of 25 puts us out at 5 for each one of these. So there's our circle. So now we're going to graph this. What shape does this make? Is it a parabola? It's not x squared. It's definitely not a circle. It's not x squared and y squared. It's just a linear equation. So it's in the format of y equals mx plus b. So we have our y-intercept at 5, and then we do a slope of negative 3. Down 3 over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1, down 3 over 1. You might even be able to go up 3 and negative 1. So that's going to give us our line. And it looks like it crosses right here at 0, 5. And 3 over, 4 down. Seems like that's where this is crossing. So if you plug the points in, 0 squared is 0. 5 squared gives you 25. Minus 25 is 0. 3 squared is 9. Negative 4 squared is 16. Added together is 25. Minus 25 is 0. So this point, actually both points, work in the first equation. 0 for x, plug in 0 for x, gives you 5 for the y, and that's what we knew it was. So this point works in that equation. 3 for x gives us negative 9. Negative 9 plus 5 gives you negative 4. Negative 4 is what we expect y to equal. So they work in both. So we call that two solutions. Okay, what shape is this? What equation? What shape does that make? It makes a parabola. Y equals a x minus h squared plus k. It's not a circle because it's not x squared and y squared. Makes a parabola, which is a U shape. So we need to look at the vertex, which is -2. It's always the opposite. -2, -3. And so if that's my vertex, from that location, I notice my A value is 1. So I'm going to do my parent graph, which we do 1 to the right and square it, 2 to the right and square it, and 3 to the right and square it. That's what x squared, the parent function of a parabola, is. So from your vertex, move 1 to the right. 1 times 1 is 1. And you can reflect that over our line of symmetry. Move over twice from the vertex. 2 times 2 is 4. So if you count up 4, you know exactly where to put the next dots. From your vertex, go over 3. How far up am I going to go? 3 times 3 is 9. And that allows me to graph my parabola. We have our equation here. We're going to have to move the x over. We like to put in slope-intercept form, y equals. So we have a x-intercept at -1 and a slope of 1, which is up 1 over 1, up 1 over 1. Down 1, backwards 1, down 1, backwards 1. We can connect those. And this is going to cross here at -1, -2. And of course, it's also crossing at the vertex, -2, -3. And if you want to take those, you can test them in here. -1 plus 2 is 1, squared is 1, minus 3 is -2. -1 for x makes this a positive 1. -2, so -2 plus 1 gives us -1. So it is a solution. It makes it work. And you can do the same for the next equation or for both. So you have 2 solutions. We can take our graphing calculator, if that's appropriate to use. You can type in that equation, x plus 2, quantity squared, minus 3. And we're also going to type in y equals x minus 1. A graphing calculator can only do y equals, so you always got to get y by itself. So if we go to the table, we can look to see if the y values are the same anywhere. Well, we expect them to be the same when x is -1. So let's move our cursor to x is -1, and there we have y values that are the same. We also expect it to be the same when x is -2. We got the answer of -3 for both equations. It's not the same anywhere else. 6 and -6, 1 and -5. They're all different. So you can test answers in your graphing calculators. Circles are tough to graph, especially on a graphing calculator. You might be able to graph that better on Desmos. All right, there's something else I wanted to show you with this. This is vertex form. But if we take vertex form and turn that into standard form, would we get the same graph? So if I convert this to standard form, multiply, FOIL together my binomials. That would be my equation that is the same as this one. I can test that out again in your graphing calculator. If I type that out, x squared plus 4x plus 1, my table should be the same for both y1 and y2. That's telling me that that equation, x plus 2 squared minus 3, and x squared plus 4x plus 1, they are the same thing. You get the same y value every time. When x changes, you get the same y. So those are the same equations. Now, how would I graph that? We did this earlier. We've taken tests on it. You need to know where your line of symmetry is. To find your line of symmetry, you want to do negative b over 2a. Your b value is 4. So that's negative 4 over 2 times 1. Negative 4 over 2. So your line of symmetry is going to be at negative 2. That's what we had. And then you could plug that back in to your standard form. This is if you're working with standard form. How would you consider graphing that? That might come up in the homework. So that's a negative 4 plus 1. We're expecting that to be negative 3. Perfect. So we have our vertex at negative 2, negative 3. And then we would go 1 over 1 up, 2 over 4 up, 3 over 9 up. So you can graph in standard form or in vertex form. Okay? Write a system of two unique linear equations. You can't make the same equation with infinite many solutions. So I'm looking for two equations that are going to produce that graph. Well, to me, that looks like we're up maybe 2. And my slope seems like it's up 1 over 1, up 1 over 1. Down 1, backwards 1, down 1, backwards 1. So it's a slope of 1. So that's my first equation. Now what else would create that same exact graph? Those same exact points? If you multiply this by a common value, let's say 4. So 4y equals 4x plus 8, and multiplied everything by 4. Now we have a different looking equation. That's all you do. Sometimes you'll see it when you minus the x across. Leave the 2 where it is, subtract it across, subtract the 4x across. Sometimes you see it look like this. There's your system. So if you were to graph that, you need to convert it over to y equals mx plus b. So you know where the y-intercept is, and you know what the slope is. Write a system of equations consisting of a circle and and a line, and they do not intersect. There is no solution. So I'm going to put a circle down in here. And then I'm going to make a line be up in here where they do not cross. So a circle, remember, is x minus h squared plus y minus k squared equals r squared. That's the equation of a circle, where my h and k is my vertex. Well, I need to come over and down the same distance. So let's do that. X minus 3 means I'm going to go 3 to the right. Plus y plus 3 means I'm going to go 3 down. Remember, it's the opposite. Different reasons for that. So if this is over 3 and down 3, and my circle is going to touch the edge of these axes, then my radius has to be 3 squared, otherwise known as 9. There's my equation of my circle. Make any equation you want. Then you need an equation of a line that's not going to touch that circle. So I need a slope that's positive, like 1x, that's fine, and a y-intercept that is positive. That's up maybe 3, and there you have it. There's a system of equations that consists of a circle and a line that do not intersect.